are going to solve some more advanced questions. All right, this is the first question. Let's go. A stone is thrown upward with a velocity of 20 meters per second. Right? It is caught on its way down at a point 5 meters above where it was thrown. Question is, how fast was it going when it was caught? Then, how long did the trip take? Right? Now, what we'll do is to picture this, right? So, let's draw a mental or a pictorial representation of the question. So, a stone was thrown upward. Let's say this is the stone thrown upward. Then, you know fully well that when an object is thrown upward, it's going to reach maximum height. Then, I'm going to stop momentarily and start coming down. All right. So before it reached the point where it was thrown, it was caught. So let's say it was caught at this point. So the question is, we find how fast. So we are looking for the velocity of the object, of the stone at this point. Now there are two ways to do this. I'm going to use some of the techniques that we learned in the last video, and then I'm going to solve it using the more advanced techniques, which is what you are required. But I'll solve it both ways so that you can juggle your memory and then understand fully. So let's go. Now let's divide this motion into two parts. The first part will be when it was going upward. Then the second part will be when it is coming downward. And then we can explain more and understand more. So when it was going upward, we know that at maximum height, its velocity will be 0 meters per second. Of course, it was thrown with a velocity of 20 meters per second. So what we'll do is let's find the maximum height attained by this object. Now, since it's going upward, our g is going to be negative 9.8. In a more advanced case, you use g as 9.8, except that it is given for it to use as 10. All right, so let's stick with 9.8. Now, the equation we use will be v squared equals to u squared minus 2gs. We are looking for the maximum height attained. So v is 0. 0 squared equals to 20 squared minus 2 times gs. All right. So since 0 squared is 0, that means our s is going to equal 20 squared over 2 times 9.8. Now s is going to equal 400 over 19.6. If you press your calculator, 400 divided 19.6 is going to give us 20.41 meters. So that means the maximum height attained by this object is 20.41 meters. Now, that means you can know the distance the object has traveled when it was caught. Let's draw the picture again. And let's say this is the point where it was thrown. Distance from here to maximum height. Let's say this is the maximum height. Distance from this place to maximum height is 20.41 meters. Now, it was caught on its way down. All right. But where it was caught was 5 meters above where it was thrown. So let's say it was coming down, and then distance from this place to this place is 5 meters. So if the whole length is 20.41, then from where it was thrown to where it was caught is 5 meters. That means coming downward, this stone must have been caught at point 20.41, 20.41 minus 5. So which is going to give us 15.41. All right. So that means the distance this object has traveled when it was caught is 15.41 meters. Now let's consider the second part of the motion. That is when the object is coming downward. When the stone was coming downward, it has traveled a distance of 15.41 meters. If the stone is coming downward, that means it must be falling from rest. So its initial velocity coming downward is going to be 0 meters per second. Your g is going to be 9.8, positive 9.8 meters per second square, because it is along gravity now. It was negative in the first case because it is against gravity. Now coming downward is going to be positive because it is along gravity. Now we can find the velocity. So finding velocity, we say v squared equals to u squared minus 2gs, v squared plus, since it's positive coming downward. So v squared is unknown. U is 0. 0 squared plus 2 times 9.8 times the distance covered coming downward is 15.41. So this times 2 times 9.8 is going to give us 302. So we have v squared equals 302 Now our V is going to equal square root of 302. Square root of 302 is going to give us 17.38. So the velocity is 17.38 meters per second. Alright, I'm going to write it here. So V equals 17.38 meters per second. So when the object was caught, it was traveling at 17.38 meters per second. Now, the second part of the question says find the how long the trip takes. So how long is time? So we want to look for the time it took for the object to make this trip. So what is the trip? The trip is the time taken for it to go upward and then to go downward till it was caught. Now, so this is what we'll do. We'll divide the motion into two again. We'll look for time taken for it to go upward and the time taken for it to come downward till it was caught. So let's call the time to go upward T1. So to get maximum height, we are looking for that. We know that at maximum height, V is going to equal to 0 meters per second. Because U is 20 meters per second. Then G is negative 9.8 meters per second squared. Right, so let's do V equals to U minus GT. Then 0 equals to 20 minus 9.8 multiplied by T1 in this case. So T1 is going to equal 20 over 9.8. So 20 over 9.8, 20 divided 9.8, that gives us 2.04 seconds. So that's the time it took to go upward. Now let's look for the time it takes for the stone to come downward till it was caught. Now coming downward, we know fully well that when an object is coming downward, it must be coming from rest because it's going to stop momentarily. So U is going to equal 0 meters per second in this case because it's coming downward from rest. Then we calculated our V to be equal to 17.38 meters per second. Then our G is going to be positive now because it is along gravity. So let's make it G equal to positive 9.8 meters per second squared. Now we are looking for T. So T2. So we say V equals to U plus GT. Alright. We have 17.38 equal 0 plus 9.8 T2 in this case now. So T2 is going to equal 17.38 over 9.8. So 17.38 divided 9.8 is going to give us 1.77 seconds. So that means the total time taken by this object, which will be our T1 plus T2, will be 2.04 plus 1.77. So this is going to give us 2.04, that is 3.81. So the time taken by this object is 3.81 seconds. So the trip took 3.81 seconds. Alright, so that is one way of doing it. I hope you understand. If I was too fast, there's a just rewind, or you can try and slow it down so that you can take it at your own speed. Now let's look at the other way to solve this. Let's use the more advanced techniques, and then if you are doing A-level exams, you should use these techniques because it is more advanced, and then I feel it is faster. So now, the other method to do this is to use our equation of motion also. But if you are solving an advanced question, the very first thing to do is to take your Cartesian plane, right? You're going to call your Cartesian plane into play. So what is Cartesian? You know fully well that if you have a graph, right, this is your positive y-axis, this is negative y-axis, this is positive x-axis, this is negative x-axis. That's what you call the Cartesian. So from the Cartesian, you see that going upward is positive, going downward is negative. That is what we use, and that is what I recommend. Although in some cases you can take it the other way around. You can take your downward as positive, your upward as negative. Whatever you do, just make sure that you are consistent. But I always recommend taking upward as positive. So that's the first thing you want to note. That's the first thing you want to write down. So we'll say take upward as positive. So it means that any quantity that lies in the positive in the upward direction will be positive, then any quantity that lies downward direction will be negative. So let's see. A stone is thrown upward with a velocity of 20 meters per second. So it means our initial velocity is upward, so it's going to be positive. So it's going to be positive 20 meters per second. Now, it was caught on its way down at a point 5 meters. Okay, so the displacement is 5 meters. All right. Then now G is negative because our G is going to be going downward. That would be negative 9.8 meters per second squared. We are looking for V. So what we can say is we use our equation of motion, or we do V squared equals to U squared plus 2G S. So V is unknown, U is positive, that's 20 squared plus 2 times negative 9.8 now. Then multiply by displacement, which is 5. So we have V squared equal to 400, pardon me, we have 400 minus 2 times 9.8 times 5, that will give 98. So V squared now is going to equal 400 minus this, which is going to equal 302. So V is going to equal square root of 302. So square root of 302 will give us plus or minus, right, 17.38 meters per second. Now, why are we taking plus or minus? Because we are putting our Cartesian plane into concern, and you know that the square root of any number can be plus or minus. Square root of 4 is either plus 2 or minus 2, because plus 2 times plus 2 is 4, negative 2 times negative 2 is also 4. So when you take a square root, it can be positive or negative. Now, which of these should we take? We know that when it was caught, the object was going downward, and we said that we take upward as positive. So that means our velocity is going to equal negative 17.38 meters per second. Negative is correct because the object is going downward. Now, in the first case, like in the first method that we did, what we're concerned about is the magnitude. But now in advanced questions, you have to take note of your direction, because velocity is a vector quantity. You have to take note of your direction. So the other way you can put your answer is to say that your velocity is equal to 17.38 meters per second, but it is downward. Okay, this will show the examiner that you really know what you are doing, and then because you've told them that you are taking upward as positive, so if it is downward, then your velocity will be negative. Right? So this is going to be more appealing to any examiner. All right, but the good thing is that the magnitude of both the velocity in the first method and the second method is the same. Now let's go ahead and look for the time. I'm going to chop this place off now. How long did the trip take? So we are looking for time. Now, how do we find the time? Use our equation again. So we can do V equals to U plus GT. Now, what's the velocity? Velocity is, we got that to be 17.38, but don't forget, we said take upward as positive. So since the velocity is going downward, I'm going to have negative 17.38 equal, the initial velocity was upward, so that's going to equal 20. Now, our G is always acting downward, so it's going to equal negative 9.8 multiplied by time. Now, subtract 20 from both sides. We have 17.38 minus 20 equal negative 9.8t. So 17.38 minus negative 17.38 minus 20 is going to give us negative 37.38 equal negative 9.8t. So divide both sides by negative 9.8. We have negative 37.38 over negative 9.8. Negative cancel negative. So time is going to equal 37.38 divided 9.8, which is going to give us 3.81 seconds. So the time for the trip is 3.81 seconds, which is also what we got in the first method. All right, so please try and understand this. That is how you're going to solve it if you are doing an advanced case. And then I just really hope that it makes sense to you. But if it does not, if it didn't make sense to you, just rewind and watch it again. So that's the first question. We still have many more to practice. Now let's see another question. Here is another question for you. It says that 3 kids in a parking lot launch a rocket that rises into the air a 380-meter long arc in 40 seconds. Determine the average speed. All right, so you can pause the video and then try and solve it first. Now, what you notice is that this question may not look like a linear um, equation problem or linear motion problem. Why? Because it says it makes a 380-meter long arc. Arc is not linear. What do you call arc? Arc is just like a part of the circumference of a circle. But what we are looking for is a linear motion parameter, the average speed. Now, remember we said that average speed, what is the formula for average speed? Average speed is total distance over total time taken. All right, that is the formula for average speed. So now, if you have an arc that is 380-meter long, all right, the motion make or the 3 kids in the parking lot launch a rocket. So the rocket makes an arc of 380 meters. So the distance covered by that rocket is the length of the arc. All right, so that is what we are concerned about, the total distance. So the total distance is the length of the arc, and the length of the arc was given as 380 meters. So your average speed is going to equal, total distance is 380, the total time taken was 40 seconds. All right, so average speed is going to equal 380 over 40. Then 380 divided 40 is going to equal 9.5 meters per second. So that is what they wanted us to do, and then that is the correct way of solving this, right? For average speed, what we are concerned about is total distance. The total distance is the length of the arc, and that is it. All right, let's see another question. Here's another question for you. You can pause the video and try and solve it. Now, the question says a runner travels 1.5 laps around a circular track in a time of 50 seconds. All right, let's picture that. So, a runner travels 1.5 laps. So, what do you call a lap? If you're an athlete, you know that a lap is running around the field. Right? The track is, it was said, it's circular. So, one lap is you go round the circular track and come back to your initial position. That is one lap. So 1.5 lap is going to be, you start from here, then you're going to stop at half of the track. So let's say you start from here, you stop here. So that is what you call 1.5 lap. You go once, then make another half. Now, the question is, we are told that the diameter of the track is 40 meters. So what is diameter? The diameter is a straight line that passes through the center of a circle. Right, so this is the diameter. It is 40 meters, and the circumference is 126. Right, so the circumference is 126. Circumference is 126 meters. Diameter is 40 meters. Now find the average speed. Right, now what's average speed? Average speed is total distance over total time. Now remember we said in the last video that the total distance is going to be, when we add the arc, it's going to be the length of the arc, right? So now, for this case, we have a circular track. So the total distance is going to be the circumference of this circular track, right? That will be the total distance covered. So, but remember that it make 1.5 lap. So one lap is going to be, circumference is 126. Another lap is going to be half of 126. That will be the total distance covered. So we're going to have 126 plus 126 over 2 for the half lap, then over total time taken, which is 50 seconds. So 126 divided 2 is going to equal 63. So we have 126 plus 63 over 50. So 126 plus 63, that is 189, 189 over 50. So what is 189 over 50? This is going to give us 3.78. So average speed is 3.78 meters per second. That is the average speed. So remember, average speed is total distance over total time taken. What we are concerned about is the total distance, which is the circumference of the arc. In a case you are not given circumference, if you are given diameter, you know that the circumference of a circle is 2 pi r or pi d. All right. So that is how you do this. I'm sure this should make sense to you. All right. So now let's see the other question. The other question says, find the magnitude of the average velocity. So we are looking for magnitude of the average velocity. Now you note that velocity and then speed, right? They are different in the sense that velocity is a vector quantity while speed is a scalar quantity. So velocity has to do with direction, while speed has nothing to do with direction. Speed is just magnitude. Now, let's draw our track again. So let's say this is our track. We said that this person started from this point and they stop at this point. The diameter is 40 meters. All right. So now, in a problem like this, what you call your displacement, because your average velocity in this case, will just be your displacement, your total displacement over total time taken, total time, right? In fact, by definition, your speed is distance over time, velocity is displacement over time. So what would be the displacement in this case? Your displacement, because it has to do with direction, your displacement is going to be a straight line that joins your start of the motion to the end of the motion, right? So the runner started from here, started at this point, all right? So, and then ended here. So a straight line that is going to join that is, as you well guess, is the diameter. Yeah, the diameter. So the diameter of this circular track is going to be your displacement. A straight line that joins the start of the motion to the end of the motion. It started here and then ended here. So that straight line that joins that part is the diameter. And then we are graciously given the diameter. So the diameter was given as 50, is it 50? The diameter is given as 40, yes, 40 over here, 40 meters. So, and that diameter is going to be our displacement. So our displacement is 40 over total time taken, that is 50. So 40 over 50 is going to give us 0.8. So average velocity is equal 0.8 meters per second. So that's what differentiates your displacement from distance, your velocity from speed. All right, so that's good. Now let's see another problem. So here's another problem. It says that a car is accelerating uniformly between two checkpoints that are 30 meters apart. So let's say this is checkpoint A, this is checkpoint B, and then the distance between them is 30 meters. Now, on that line accelerating uniformly, right? Now, the time taken between checkpoints is 4 seconds. So, time taken to go from A to B, or the time it took for the car to go from A to B is 4.0 seconds. And the car speed at the first checkpoint is 5 meters per second. Good. So, we are given the velocity at this point is 5 meters per second. Find the acceleration, right? The uniform acceleration and the speed. So that means we are looking for the acceleration and then the final velocity at checkpoint B. So how do we do this? Let's take out our parameters. Our u is 5 meters per second. Now, for us to look for the acceleration, because the acceleration is uniform, that means is constant throughout the motion, and then that means the acceleration at point A is going to be the same at point B. That means we can say that let's find the acceleration when the object has covered the whole distance. All right. So the distance covered is 30 meters. Now we know that the time taken for it to accelerate to that point is 4 seconds. Then we can say that use our equation of motion that says s equals to ut plus half at squared. That is the equation that has all the parameters. So our s is 30, u is 5, multiplied by time is 4, plus half times a is unknown, but t squared, that is 4 squared. So 30 equal 5 times 4 is 20, plus 4 squared is 16, half of 16 is 8. So we left it 8a. So subtract 20 from both sides. 30 minus 20 is going to give us 10 equal to 8a. Then a is going to give us 10 over 8. 10 over 8 is going to give us 1.25. So acceleration is 1.25 meters per second squared. So that's the acceleration. Now the second part says find the velocity. So we can simply use v equals to u plus at because it's accelerating uniformly. So v is unknown, u is 5 plus acceleration is 1.25. The time taken for it to accelerate is 4. 1.25 times 4 is equal 5. So v is going to equal 5 plus 5. It's going to give us 10 meters per second. So that is the velocity at checkpoint B. I believe that is quite simple enough and easy to understand. Now let's see another problem. So here's another problem. Yes, this is an interesting one. A body dropped from a balloon reached the ground in 20 seconds. Determine the height of the balloon if in the first scenario it was at rest in the air, then B, it was ascending with a speed of 50 meters per second when the bottle was dropped. All right, so let's see what that is saying. So let's say this is a balloon. Let's say this is a balloon. So a bottle was dropped. At first, it was at rest in the air. So if it was at rest in the air, that means this bottle is going to be dropped from rest, meaning that initial velocity is 0 meters per second. All right. Now the time taken for it to reach the ground is 20 seconds. Now the question is determine the height of the balloon. Now the balloon is a particular height from the ground, so we are looking for the height at which it was from the ground. That is, we are looking for our s. So if you say I always take upward as positive. All right, so if you take upward as positive, right, that means in this case now our g is going to be negative because it's coming downward. Then our displacement is also going to be negative because the height, we are looking for the height of the object now. That is the height this object is going to fall, the body is going to drop from where it was dropped downward. So the displacement is negative, it's going downward. So if you take upward as positive and then you plug in your equation of motion, the equation of motion that is going to have all of this is going to be s equals to ut plus half at squared, right? So in this case now, our displacement is going to be negative. So let's say negative s equal, since it dropped from rest, c is going to equal to 0. 0 multiplied by the time is 20. Now minus, because g is negative, half times 9.8 multiplied by the time is 20 squared. So negative s is going to equal 0 times 20 is 0. Half of 9.8 is 4.9. So we have negative 4.9 times 400. So negative s is going to equal 4.9 times 400. That is 1960. So negative 1960. Negative cancel negative. S is equal to 1960 meters. If you want to put it in kilometers, we have divided by 1000. So that's going to give us 1.96 kilometers, approximately 2 kilometers. All right. So please understand the Cartesian rule that I used there, because it is important, and then it's going to make you understand reading some advanced textbooks. Most people say I have problem understanding holiday. That is because you do not understand some nitty gritty. So if you understand this, you're going to understand reading some more advanced textbooks. So now the second question says, find the height of a balloon if it was ascending with a speed of 50 meters per second. Now it is because of this second question that I make use of this Cartesian plane, because it's going to come into play when we are solving the second question. So now let's solve the second question. Now, so in the second question, the balloon was not at rest. The balloon was going upward. All right, so it has initial velocity. Right, so in the second problem, the balloon was going upward. So that means this balloon, let's say this is the balloon. So the balloon is rising, and then it has an upward velocity of 50 meters per second. So remember we said always put this first, take upward as positive. So that means the velocity is no longer 0 now, because the object has an upward velocity, upward initial velocity. So our u is going to equal positive 50 meters per second. All right, and then our g will be negative 9.8 meters per second squared. We are looking for the height, that is s, and then the time taken is t 20 seconds. So plug in. So we do s equals to ut plus r gt squared. This displacement is downward, so it's going to be negative. So I'll write negative s equal, this u is positive because it's going upward. So that will be 50 multiplied by the time taken is 20, then minus half times 9.8 times 20 squared. So we have negative s equal 50 times 20 is going to equal 1000, minus half of 9.8 is 4.9. 4.9 times 20 squared is, if you remember in the last problem, it was 1960. So we have negative s equal 1000 minus 1960 is going to give us negative 960. So divide both sides by negative 1. S is going to equal 960 meters. And if you approximate that to kilometers, or if you convert it to kilometers, it's going to have 0.96 kilometers. So that will be the answer to this problem. Let's go to the next one. Right, this is another problem for you. You can pause and solve first. So now let's go. Two balls are dropped from different height. One is dropped 1.5 seconds after the other, but they both strike the ground at the same time, which is 5 seconds after the first was dropped. Now the question is, what's the difference in the height from which they were dropped? And then another problem is, from what height was the first ball dropped? So now let's try and understand this. Let's put it into diagram for us to for it to make sense to us. So two balls are dropped from different heights. One is dropped 1.5 seconds after the other, but they strike the ground at the same time. So if two balls are dropped from different height, and then they reach the ground at the same time, what it means is that, let's draw something. So let's say this is the first ball. Then let's say the first ball is above, and then of course, the second ball is below because they were dropped at different height. Now, for them to reach the ground at the same time, what it means is that the second ball must be dropped when it is at the same level as the first ball. That the first ball was coming down, so when it got to the um, height of the second ball, that is when the second ball was released. That is the only case in which they will reach the ground at the same time. Otherwise, they will not reach the if they were not at the same height, right, they will not reach the ground at the same time. Remember what we said in the last video about the stone and the feather. So that means the second ball must have been dropped when the first ball reached the height of the second ball. And then we are told that the time taken for this um, is 1.5 seconds. So that means this second ball was dropped after 1.5 seconds when the first ball was dropped. And then we were told that the first ball, okay, reached the ground after 5 seconds. See it here, it says at the same time, 5 seconds after the first was dropped. Okay, so what it means is that the time spent in the air by the first ball is 5 seconds, and then the time spent in the air by the second ball must be 5 seconds minus 1.5 seconds, because it's going to take the first ball 1.5 seconds to reach the height at which the second ball was dropped, right? Two balls are dropped from different height. One is dropped 1.5 seconds after the other. Okay, so that means the second ball must have been dropped 1.5 seconds after which the first ball was dropped. And 5 seconds minus 1.5 seconds is 3.5 seconds. So it means that the second ball was dropped 1.5 seconds later, and it means that it spent 3.5 seconds in the air. So what is the difference in the height from which they were dropped? So what we just simply do is calculate the height of the first ball, calculate the height of the second ball, and then subtract. So height of the first ball, let's call it h1. So since they were dropped from rest, the initial velocity will both be 0. So we can just do s equals to ut plus half dt squared, right? All right, let me put the Cartesian into play because we are doing advanced questions. So let's say take upward as positive. Take upward as positive. So what it means is that our g will be negative, the displacement will be negative because the object is coming downward. So we say negative s equals to ut minus half dt squared. So negative s, which is unknown for the first ball now, height of the first ball, so let's call it s1. Negative s1 is going to equal u is 0 multiplied by the time spent by the first ball in the air is 5 seconds minus half times g is 9.8 times squared is 5 squared. So we have negative s1 equal 0 times 5 is 0. Negative half times 9.8 is 4.9. 5 squared is 25. 4.9 times 25. So s1 is going to equal negative 122.5. Right? So negative cancel negative. S1 is going to equal 122.5 meters. Okay. Let me go through that again to be sure that everything is correct. Half times 9.8 is 4.9. Then the time spent by the first ball in the air is 5 seconds. 5 squared is 25. 25 times 4.9 is 122.5 meters. All right, that is correct. So let's leave that somewhere. Let me erase this part so that we can calculate time for the height of the second ball. So the second ball was dropped 1.5 seconds later, and then we established that it spent 3.5 seconds in the air. So we say S2, let's call it S2, negative x2 equals to ut minus half gt squared. So negative s2 is going to equal 0 times 3.5 minus half times 9.8 times 3.5 squared. So 0 times 3.5 is 0 minus half of 9.8 is 4.9 times 3.5 squared. So 3.5 squared is 12.25. 12.25. So negative x2 is equal to 4.9 times this, which is 60.025 meters. So the height, all right, negative. So negative cancel negative, x2 equals 60.025 meters. Now we can find the difference in their height. So what will be the difference in their height? We'll establish that the height at which the first ball was dropped is 122.5 meters. Then the height at which the first, the height at which the first was dropped is 122.5 meters. The height of the second is 60.025 meters. Now we can find the difference in their height. So the difference in their height is just going to be subtraction, subtract those two. So difference in height, change in s is going to equal height of the first minus height of the second, which is 122.5 minus 60.025. So 122.5 minus 60.025, that's going to give us 62.475 meters, which is approximately 63 meters. So that's the difference in the height. I hope that makes sense to you. Then for the second question, it says, from what height was the first ball dropped? Right. So we've indirectly calculated the height from which the first ball was dropped and calculated it as 122.5 meters. Right. So I hope that makes sense to you. Let's see. I think that is all the questions that we have for you. So please, I'm sure that you have learned quite a lot. So please keep practicing. You can solve more questions. If there are any questions that you have solved on motion that you're not able to do, you can put them in the comment section. If you gather enough, I can make another video and solve those questions for you. Then also we have a Telegram channel. We can put you into Telegram channel where you see more of our questions that have been solved. So thank you for watching this video. Please, you can subscribe, like the video, make a comment, share the video. I promise you we have a lot of stuff to dish out to you, and then you are really going to learn a lot. Thank you. I'm going to see you in the next video.